Okay, so we're doing the final review. Um, the final will open up on Sunday and be available till Wednesday night at midnight. So let's talk about what's important here. I need things in your own words, not in somebody else's, not taken from the internet, not anywhere else. I just need you to get your stuff together and take care of your business. I would appreciate that. Okay. If you bring me canned answers that you found on the internet, pretty much I'm going to disallow it all. Okay. All right. So here we go. Final review. First thing you have to remember is the central tendencies. First, it's the mean and how to calculate it. You should know this. Look it up. Look it up. Do what you got to do to make it happen. Okay. Okay. The mode, the median, the range, how to calculate the range. And remember, the standard deviation is the dispersion from the mean. Qualitative and quantitative. Okay. Qualitative is words words or anything like that, and then nominal words, things, and let's say like my name, Jeff Ianson, that would be a nominal type of a variable. Numerical is also called quantitative. Quantitative is also called numerical. Okay. Population. Population is every person. The example would be every person in the United States. That would be everybody. But again, it's hard to do everybody. So you pull a sample, which is a subset of the population. Next one up, descriptives and frequencies. Okay, descriptives and frequencies. Descriptives and frequencies tell us all about our participants. Okay, in a general term. Descriptives give us a range and a standard deviation. Frequencies tell us how many participants fall into each category and with a number and a percentage. Normal distribution, equal sides, mean, mode, and median are equal. You can see the bell-shaped curve here. You can see the bell-shaped curve here. This bell-shaped curve. Okay. Next one up is kurtosis. Kurtosis is the peak of the curve. Okay, you'll see the three different kinds here. One is platykurtic. The smallest one is platykurtic, mesokurtic, which is almost like a normal distribution, and leptokurtic. Okay, remember, kurtosis is the peak of the curve. Two different branches of statistics, descriptive and inferential. Okay, descriptive and inferential. Let's go over the p-value of the significance right now. Remember that the p-value, the magic number is 0.05. Magic number is 0.05. Okay, remember that non-significance is above 0.05 and significance is below 0.05. P is written like this. P is either greater than 0.05 or P is less than 0.05. Okay? Right. Next one up. Null and alternative hypotheses. A null hypothesis is a prediction of the results of a research study. Null, it means no difference, and alternative means different. Correlation is a relationship between two variables. measures the strength and the direction of the two variables. And also you need to understand what a scatter plot is. That's what we look at when we're looking at the correlation. It tells us, it gives us a visual picture of the direction and the strength of the correlation. Strength and direction, okay? Direction, positive or negative. It's just as straightforward as that, okay? Strength and direction. Remember, 0 is in the middle. Negative 1 and positive 1. These are perfect, okay? Anytime you see a 1, it's perfect. 0 means no correlation. So if I give you a number of 6.625, negative, and positive 625, these numbers are exactly the same. They just show direction. That's it. Okay? Remember, it's 3, 5, and 7. Small or slight, moderate, and anything above a 7 is high. But remember that these two things are actually equal. Okay? What those numbers tell us, again, what the numbers actually tell us, if I was to take that 645 again, 0.645, and it's positive, it tells me that both scores went up. If it's negative 0.645, one set of scores went up and one went down. That's it. Okay? This right here would be a moderate positive correlation, and this would be a moderate negative correlation.
You guys here?
I'm here. I've already started.
I'm here.
I'm here. Sorry.
So remember that your strength goes by the positive or negative mark, and it's 645. And remember, if it's positive, both scores go up. If it's negative, one score goes up and one score goes down. Okay? Let's go over the correlation box. The correlation box is relatively simple if you remember the things that are important. Remember, we're dealing with the Pearson correlation right here. Okay? That is your R value. Okay? The number 1 here and the number 1 here in that Pearson correlation line means it's perfect. Okay? Means it's perfect. All the scores equal. Okay? Over here, you can see the Pearson correlation of 0.520. Okay? And this way we have a moderate positive correlation. Okay? And down here we have the same thing. It's going to be the same thing. And then this tells me there was 412 participants, and being this is 0, 0, 0, it was significant, not non-significant. Okay? Okay? Here is your scatter plot. Okay? First off, we can see that the line goes in this direction, not this direction. So we already know that it's positive because the number was there. We have a positive correlation here. All right? So both are going to go up. So as reading goes up, so does, what's the other one? Math. Okay? If it's a positive, both are going up. If it was a negative and it went the other direction, as math went up, reading went down. Okay? Paired sample t-test. The paired sample t-test tests a variable at different times to examine the means difference. Okay? It's done in a pre and post test, and of course it has to be separate. So math and English would be separate. two different times would be different. Anything that's separated by a period of time, or they're completely separated. They could be relatively equal, like a math and an English score, but most of the time you're going to do it by time or by two different sets of scores. And here's the paired sample output and the box. Okay. Remember, your most important part to draw an analysis is right here in the means. You're drawing an analysis in the means. I need somebody to mute your.
Sorry.
That's okay.
How do I mute it? Oh, wait, no.
Should be in the corner somewhere.
Gotcha.
Coolio. All right. You're looking at the means. Okay. The means here are relatively close. This is father's highest year of school completed, and this is the mother's. So the analysis is extremely simple. Okay. The analysis is that the fathers completed more education than the mothers. That's it. Here is your standard deviation, and it was done on 1,796 participants. Okay. Remember, this is your most important part when you're doing your analysis. What do the means say? It's one's higher than the other. So, I mean, you just draw a sentence from there. This sentence would be simple as in this study, the fathers completed more schooling than the mothers. Done. Keep it simple. Okay. Oops. All right. Now we have our t value. Oh, and this came out really bad. So I'm going to draw on here. This is a t. This is your df, and this is your significance. So your t is, I'm sorry, your df is 1795 equals, and then there's your t value of negative 2.32, and p is less than 0.05 because this is lower than 0.05. Okay. The one sample t-test. Okay. Again, we are dealing with the mean. Okay. The mean here is 50.90. In the next slide, you're going to find out that, remember, I'm sorry, let me go back real quick. The one sample t-test tests one sample vs a test value or a criterion value. Okay. So it's one sample versus a test value or a criterion value. Okay. You're looking at if it's above or below. So going back to this one, the test value here is 40. It's right here in this box right here. It says 40. And anything you're going to do, it's going to be right there. So this number right here is 50.90. Okay, which is above 40. So if it's above 40, they're working 10.9 hours more than whoever was running the test believed. Okay, so your analysis is real simple. The mean score of 50.90, you could say it this way, 50.90 is 10.9 hours higher than the test value of 40 hours. That's it. Very straightforward. Again, unfortunately, it wouldn't change on me, but the standard deviation is 14.95 and 15.79 is your number of participants. Clear, close. Got it right this time. Then again here, this is where you start at the very beginning. Find out that test value in a one sample t-test, and then look, is it above or below? Here's your t, here's your df, and the significance, it was significant because it was below 0.05. independent sample t-test. An independent sample t-test looks at the means of two variables. Okay, means of two variables. Two variables, male, female, yes, no, anything like that. So we're using our male and female here. Here's our male and female. Here's how many females, here's how many males. So there's more males than females, okay? In this case, we're looking at the English grade. So even though it's real close, the males were just higher. So your analysis is done right in this box. This is where you're looking for your analysis, okay? In this case, the males' English scores were higher than the females' English scores. That's it, nothing more, nothing less. Here's your standard deviations if I ask for that. But again, your means is where you're looking. You're looking at your means here. The mean is very simple. One will be higher than the other, okay? And you draw your analysis from that statement right there. Okay, oh, that didn't come out right. That should be the Levine test of equality of variances, okay? Remember, if this number right here, so this goes to these two right here, okay? This number, if it's above 0.05, you're taking this line. If it is below, you're taking this line. So it's above, so we're taking the top line, okay? So we're gonna take the F of negative 0.21, we're gonna take the DF of 407, and 0.84 is your significance, and that's above, so this is non-significant. Above 0.05, non-significant. Remember, these two are separated. Whenever I did this in class, I always took this and I made a line right here so I didn't get them mixed up. This significance goes only to decide whether you can use this one or this line, and that's it. This is for the actual test over here.
So we don't actually use the significant on the very right?
On the very right, this significance right here is for the actual independent sample. This one right here is only to decide whether you're using this line or this line.
Okay.
Okay, so this would be written F, and then the DF is 407, okay, equals negative 0.21. P is greater than 0.05. P greater than 0.05 is that number right there, 0.84. Okay?
Okay.
All right, one-way ANOVA. Remember, the one-way ANOVA does two things. One, you're still looking at the mean. Okay? All right? And in this case, you have these means right here where your high school student, these are IQ scores. IQ scores. So the high school student had a higher IQ score than the middle school student and higher score than the elementary school student. Again, these are your standard deviations. Okay? Overall, this is the overall, but this is what the high school student had, this is what the middle school, and this is what the elementary school student has for an IQ score. Okay? So if I ask you the mean of the middle school student, you put 35.87. Okay? Now remember, the one-way ANOVA looks at 3 or more groups. Okay? 3 or more groups, and it looks between the groups and within the groups. That's why there's these two DFs. So in this case, the F value here is 20.02. The DF is two numbers. It's 2 and 42. Okay? This is between the groups because you have 3 groups. You're taking one out as a, like I call it, you're working around that one. But then if you're going between the groups, you're going through all the groups, all the pairs, and there's 42 pairs. Okay? So you need both. You need to know both DFs.
Really quickly, what's the difference then between the ANOVA and the post hoc? Because I thought the post hoc looked at between and within the groups also.
No, it doesn't look between them. I'm going to that next. Give me
Okay.
1 second. So here's the post hoc for this. Okay? The post hoc looks at each of the pairings separately. Okay? If I just went with what was there before, then what happens is that I run into the problem here that I won't be able to tell which group. So like when you look at the means, when we looked at the means in the 2 slides before, they just basically told us what? They told us that that there was one was higher than the other. But now which groups are significant between themselves? So if you look here at this slide, oops, did it again? Hold on, you can look at the slide right here, and you can see that elementary to high school student is significant. Okay, middle school to high school student is significant. Okay, and if you go down to high school, you're going to see that elementary and middle school. So if you just went to this one, you'd be able to see that all 3 of these are basically, all of them are significant on the last one. Okay, so if I asked you the question of which of these are significant, you would give me elementary, high school, and middle school. Those are the significant ones. Okay, so these have significant value, whereas the other ones with a significance of 1 are non-significant. Okay, does that make sense, Ashton?
Yeah, that does. Thank you.
Okay. Clear, close. And that's all you need to know for the final. Any questions?
So for the worksheets, it asks like, oh, like what are the variables? And usually like it asks one of them, I forgot which one it was. I think it was the ANOVA
Uh-huh.
with like the Black, white, and Latino. It asked for like
Right.
what are the 4 variables, but there's only like 3, which is Black, white, Latino. Do we add like the total?
For what, in the post hoc?
Remember which one it was. Let me check. Might be post hoc.
Okay, in that one I asked you for every one that was significant, which means you were going to put one of them twice.
One of them twice?
Yeah, I would end up having one of them twice. Because if you went white, let's say white and Latino, and then white and someone else, there, if let's see, white and Latino, white and black. Just for
Oh
example.
no, not that one. It was the one above that. Forgot which one it was.
In mine or in yours?
In mine.
Okay.
Let me hold on. Independence. Yeah, it was in the one-way ANOVA.
Okay. What's the question?
It says, what are the 4 variables being tested? But there's only Black, white, and Latino. Do I also add like the total number of participants?
No, and it's probably an error.
Oh.
I'll have to go back and check it.
Okay, so it's only 3.
There's only 3.
Wait.
Wasn't there a 4th variable?
No, it's just Black, white, Latino, and then the total number of participants.
I'll go back and check that. I'll make a note and go back and check that.
Okay.
Any other questions?
Hold on, I do have several. So the final faith integration.
Right.
That's a part of our final.
Right. It'll be a question, and you're going to copy and paste the answer right into the box.
Okay. got it.
Quick question. Can you guys see me?
Yeah.
Yeah, you're looking beautiful tonight.
Oh, thanks. I just got back from the gym. Wait, are you for real? Because I don't have a little screen up here.
There should be a box somewhere where you can put the screen up.
For the
I see
paired,
you right there.
What? How come I don't
I
see
see
it?
you. I don't know.
Says,
There's got to be
it says
something you
my
can
internet
press to
connection
bring up
is
the pictures.
unstable. What's
I can see you. You're wearing a
All right.
hat.
Are there any other questions?
Oh yeah. Sorry.
Okay.
what's going on?
When for the paired samples test, and it's asking
Right.
like to make a concluding statement for the scatter plot. Can
Uh-huh.
I put that there's a positive correlation between the two variables? Is
No.
that no?
Remember, at that moment, you're talking about two variables. One has, if it was a positive, both variables go up. As blank goes up, so does blank.
Oh, okay.
If it's negative, it's as blank goes up, so and so goes down. All right.
All right. I'm gonna turn in a lot of different files tonight.
Okay.
Um.
So what happens here is as soon as I get home, I will I'll upload this to Camtasia, and then I will post this whole thing in the room so you can watch it.
Oh, okay. Oh, it's recorded.
Yeah, I recorded it.
Oh my god.
Okay. And then it will be available till Saturday night at midnight.
Okay.
It
Cool.
won't be available for the actual test
Okay.
because those people that don't watch it and that don't miss out. You know, I'm basically giving you a roadmap to get a good grade. So take this and make your notes and everything else, and you'll be just fine.
Okay.
Because I made a list of every question there was, and every question has been is in this video. Not question, but every topic is in this video.
Okay. Let's see. Sorry.
All right, I'm gonna stop the recording.